Yeah, hi everyone. So, lot of interesting presentations for last couple of days. So today I'll be covering some of the sonic management aspects. So we have talked about Psi, we have talked about SyncD, different features, and so on. So this presentation is mostly to cover the nitty-gritty of ensuring test coverage for newer products. So we all use sonic management for testing. So I'll cover why are the tests getting skipped on your products. So about me, so I am Prasoon. I worked in a few networking companies and I joined NextHop a few months back. So I work in the areas of Psi, SyncD, platform, work as a developer there. So this is the agenda of the session. So I'll cover the motivation and the problem statement, the challenges that we have in sonic testing, the proposal that we are going to make. It's called TIE. So it's inspired from Psi. So Psi is switch abstraction interface, TIE is test abstraction interface. So I'll be covering the architecture and design, some of the benefits offered by TIE, example usage, and next steps. So this is the agenda. So what is the motivation? So Sonic is deployed across diverse ASICs. So Tomahawk, Jericho, Mellanox, and so on. And we have tests embedding ASIC-specific logic. So for the last few weeks and months, we have spent considerable amount of time understanding the test side infra for QoS, MMU, and areas around ECN, PFC, and so on. So for those who are new to QoS and MMU, so QoS is basically quality of service. So it defines how the traffic is prioritized, queued, and scheduled. And it plays a significant role when you have congestion, right? That's when multiple ASIC, they have this buffers to account for packets when there is congestion. So in-flight packets are stored in MMU. And so that's about MMU. So let's move ahead. So what is the motivation? So we have different chips exposing QoS and buffers differently. So for example, the buffer sizes and thresholds vary across different chipsets. So for example, Tomahawk 5 has larger dynamic pools. Jericho is VOQ based. And the calculation, headroom calculations, the cell size, pause thresholds, all these are different, right? So how do we make sure they are standard enough for anybody who is trying to adopt sonic management on your products? So yeah, these are the challenges that we have today. Q and PG mappings are not uniform. And sonic management, basically, the tests are embedding the logic. They have conditions per chip, per platform, and so on. It becomes a bit tricky if you try to just run the test. You are bringing up a platform and you are running the test. Most of the tests get skipped. So it's not very easy to figure out whether the tests are getting skipped because the product doesn't support the feature, or whether the support has to be added explicitly for that platform. So these are the challenges that we have. So skip tests. So when we brought up our platform, out of 150 tests, only 30% of the tests were running properly, and rest of them were getting skipped. I'm only covering the QoS, buffer, and areas around PFC. So for example, buffer profiles, they differ across ASICs, and we have a few tests in sonic management covering buffer schemas. So they embed the platform-specific logic. For example, Mellanox, there is a specific check. For Cisco, there is a check. For Broadcom, specifically for Tomahawk 4, Q3D, and so on, there are checks. Right? So basically, the test has like a bunch of if-else spread across. And if you have to add or validate a new feature or existing feature, right, you have to modify a lot of files. So you have to modify the conditional file to remove the condition for the skip. You have to go and add your platform check in the test. It's not very convenient. So what is the proposal, right? So we are proposing something called as test abstraction interface. So basically this will decouple the test logic from platform. So the test logic can do end-to-end test can do end-to-end testing, right? Without bothering about whether the platform has the support or not. If the support is not there, unsupported return type will be issued to the caller. If the support is there and it's not implemented, you fail fast. So if you fail fast, you prioritize your thing accordingly. So today, if they are just skipped, right? So you spend weeks figuring out why are they skipped, whether the condition file has to be changed or whether the test has to be modified. So again, this is inspired by Sai. So this provides a test-facing abstraction layer. This encapsulate hardware and platform differences inside adapters, and it will be pretty much object-oriented and modular. Right? It can leverage Sai APIs. So there are tests for Sai, right? But not all Sonic management tests use Sai. So tests which are using Sai can actually leverage this functionality. So this is the architecture. So I'll talk about the core components, and then we can look at the sample code. So there will be a feature adapter base, which will define standard methods. For MMU, we'll have this get lossless PG, validate buffer profile, and so on. There will be a registry which will map the platform to the right adapter, and then we'll be having platform adapters. So platform adapters can fetch data in different ways, right? You don't have to put the logic within the test. You can just have separate adapters per platform or per chipset. So yeah, so this is the flow diagram. So at the top, we have the Sonic management test suite. So all the platform agnostic test logic will be put there. So tests will no longer have any platform-specific checks. The tests will call the TIE APIs, similar to how SWSS SyncD calls the Sai APIs. It's exactly similar. So test abstraction interface basically acts as a unified API shield for the test cases. So it will define generic methods, and it's up to the adapter to define or implement the methods. So I've given some examples, but it's not limited to these ASICs, can be leveraged for other ASICs also. Any questions so far? Okay, so this is one of the example interfaces. So the base class is the QS adapter base. So it will basically just declare the methods that the lower layer or the abstraction layer will implement. The registry will get the adapter and map it to the right platform. And then comes the adapters. So basically those will implement the methods that currently the logic is actually in the test. So those will be just separated out and put in different wrappers. So what are the benefits, right? So same tests can run unmodified across platforms. So if the tests get skipped, you get a notification immediately saying the adapter is not implemented. You fail fast. If the test, so there are cases where the tests are not even supported. So in that case, you get another notification saying the test is not supported, right? So basically, your test engine will not schedule the tests next time. So you'll have slightly higher pass rate, and then you will not emphasize a lot on which files to edit and whether to remove the checks from the conditional file and so on. So it's maintainable enough. So the platform logic is centralized. You don't have any if checks in the tests. Any new vendor trying to onboard a new platform, it will be scalable. It's faster, right? Because you fail fast, you put proper emphasis and you prioritize the failures accordingly. And it's consistent across different ecosystems. So there is no chip embedded stuff anywhere. So these are the next steps. So we'll finalize the TIE interface specification. We'll have a HLD review. We'll send it, the PR will be sent in a few weeks. We'll actually prove that this works for few key test cases. So buffer profile, ECN, and scheduler, some of them. The existing helpers, we can refactor and Tye can adapt to it. And then whatever feedback we get from the community, welcome. So the idea is to make sure it's standard enough so that any vendor, anybody can contribute and leverage the benefits of Sonic management. Any questions? I hope it's self-explanatory. So. Yeah. Please.
Hey, thanks a lot. I think maybe we can directly talk about OC test suite, right? Because we have covered a lot of details. We have test COSI,
Correct.
right?
Yes.
And where this layer is going to be sitting, because for Broadcom, we don't have specific keys for TH4, TH5. We have DNX or Broadcom. Indeed, we introduced Broadcom also. Under the hood, we are also trying to put our SKU and try to make some refinements. Where this layer is going to exist, so maybe you can explain for both Snappy as well as the PDF-based tests.
Sure. Okay. So you talked about TestQSI.
Yes.
Uses PDF, but
Yeah.
Psi Thrift library, right?
Yes.
So not all the tests are using Psi. Some of the tests use Psi. Some of them directly read from the CLI, from Redis, and embed specific logic within the test, right? So this will be above Tye, above the test QSI. So test QSI also has checks. If you go and look at the tests, right, there are checks in areas like headroom calculation, right? You will see specific checks. So you don't need those. You can actually, the test can independently run, right? The platform specific logic, whether it's for say DNX, XJS, Cisco, you can actually put it in a lower layer. So it will work across different variants.
Okay, I see. That's where the headroom, because there are several topics we can touch.
Yeah.
Let me start with headroom.
Sure.
Headroom, Broadcom provides a profile, okay, because they define the number of, the amount of reserved space,
Yeah.
also the cable length, and what they can, if it's a single ATM or multiple ITM, they don't, Broadcom doesn't support MAC level buffering too much, okay? So like Cisco, because I worked in Cisco also, we have. And how are you going to homogenize this configuration? Because Marvel may have a different latency, because for RTT, you have a different headroom calculation.
Correct.
And Broadcom is having, they gave me a Excel sheet. Please apply based on this cell size for this Trident 4 or TH4, TH5, and for DNX, for varying optics. So how easily it is, how we can seamlessly homogenize with a single number is not quite clear to me.
Okay, so
to abstract it.
Yeah.
Because these are very tricky,
Correct. Yeah. So that's where these adapter plugins come into play. So the logic for the headroom, for example, some platforms might not even support it, right? Dynamic buffering, for example. The test doesn't care about those things, right? It's up to the lower layer how they implement. Whether it's supported or not, you get the notification immediately while running the test. Currently, if you run the test, you will fail, or it will say skip, right? You will go ahead and look at the test, whether there are checks or not, right? So this is kind of independent from the vendor-specific stuff. So it just sits above the adapter, right? So there are adapters implementing the methods, right? So just above that, there will be a layer which will just abstract everything out, similar to Psi.
Okay, so do we...
Think of it like Psi for tests.
Okay, so are we planning to remove profile.ini? No, right?
Can be removed. Can be removed, depends.
Okay. That.
So, sorry?
Who is building these adapters?
Yeah, it's the vendors.
Vendors are providing, okay.
Anything else? Any other questions?
Yeah, thanks.
Thanks everyone. Yeah, I think.
Okay. Prasoon, you have touched a topic that many of us would have gone through, burnt our fingers. Okay. Getting test cost, I pass, getting the right cost param generator, all these things, right? So I think many would appreciate the problem. Okay. And one question I had, one concern is, right, how do you make sure SAI, the whole idea of SAI was to make it standard, the behavior is standard.
Correct.
So irrespective of whichever the vendor, behavior is standard. And by design, most of the buffer in each ASIC, the behavior is different, how the headroom works.
Correct.
And you would have configured some hex of buffer size, right? But if you look at the cost params, right, each ASIC will have a different ways to say only if this many cells packets are sent,
Correct.
then a POS frame is sent, right?
Exactly.
Now, given all these differences, test abstraction interface is at one level, makes it easier to at least read the test case. Today, it's very difficult to understand test cost, right?
Yeah.
That's the first step, a great step.
Yeah.
The question is from end user, right? They want to see everything work based common. Right now,
Sure.
even though the tests pass, each chip is doing something different and they are passing.
Correct.
For the end user, the problem still remains that the test, there's a capability, but capabilities are different. What you get in each ASIC for the same configuration is different.
Right.
What I mean is the buffers are JSON to J2
Yeah.
or cost JSON,
So
right?
there are three parts to it, right?
Yeah.
The first part is to make the tests generic enough. If you are running an end-to-end test, you just are validating the feature. You are not validating the ASIC, right? For example, you send some packets and you see whether the buffers are exhausted or the PFC works, the feature works or not. That is the end goal. So the end-to-end test can remain the same. The test logic can remain completely abstracted. It doesn't have to know what's below the test. For example, below TIE, right? It doesn't need to know. From the test point of view, what it has to do is just invoke a method, right? Whether the method is implemented, whether it's supported, or how vendors are doing it, test doesn't care about all those things.
Okay.
Right? So the idea is to make sure tests are completely agnostic of the knowledge of the platform, so that it's easier for any vendor to just start running, and then if it's not supported, they can just add one adapter and things will work.
Okay,
That's
so
it.
what I understand is, we'll make sure the functionality works,
Yes.
but actual sensitivity, granularity, other things, we'll leave it to the vendor-specific
Exactly,
configurations.
yes.
But top level, it works, right?
Correct.
Yeah.
For example, say you are working on a TH6 or say Q3D, right? Right now, if you make a change in the test, it's up to you to test it across different ASICs, because you are changing the test itself,
Okay.
right? If
Okay.
you add a new layer, which can just abstract things out of it, right? And you just implement the adapters per ASIC, you don't have to test for all ASICs.
Okay.
That is one of the biggest advantages.
Okay. And just last thing, you wanted to do something on SAI, right? You need a bunch of get-only attributes, read-only attributes. For example, right, simple things would be, what's the cell size?
Correct.
Or given this configuration on this port, what should be the headroom size?
Yes.
Maybe we need some kind of read-only attributes in SAI
Correct. Yes.
to help some of the things. Right? Okay.
Exactly. So we'll propose the HID, and then
Okay.
we can take over.
Thanks. Nice talk. Great.